Hello and welcome to today's session. This is a continuation of the lecture that we had yesterday regarding descriptive statistics. Today we'll be using those commands to solve a few problems. I'm your instructor Rajesh Durbala. I'm an assistant professor in business analytics and research methodology. So let's go ahead and see what's in store for today. This is just a recap of some of the functions that we may use irrespective of the commands that we learned yesterday. These are in addition to those commands that we may require while solving the problems. Okay, so let us see. If I need to count the number of elements in a vector or a variable, this is the command length in brackets x. You get the number of elements in that vector. Likewise, if I need to find the ith element in a particular vector, and for instance let us say I is 2, I refers to, let us say, index. Okay, so I need to find what is there in the second place of that vector. Index is 2, then the command would be x square brackets 2, and just the inverse of it, I need all the other elements except the ith element. Then the command is just the same, just replace 2 with -2. Okay, now I need first k elements, then it would be x 1:5. Now last k elements, then x square bracket length x, that is the total number of elements, -5, okay, is to length x. That is to say, if I have total 10 elements, that is to say, when I run this command length x, I get 10. Then now I will write 10 minus 5. Okay, so if I'm looking for the last 5 elements, so I'll write 10 minus 5, that is 5. X square bracket 5 is to length 5. Okay, length of the that is length of the variable x, that is 5, is to 10. Okay, starting from 5 ending till 10. Then specific elements. Now if I'm looking for a specific element, let us say first element, third element and fifth element, then as simple as that, x, then square bracket c, that is create or combine or concatenate 1, 3, 5. These are the index. Okay, first, third and fifth. Then all the elements which are greater than some value. In this example I have said greater than 3, let us say, so it will be x square brackets x is greater than 3. Okay, likewise if I say bigger than or less than some value, now let us say if I'm looking for something which is less than, okay, or greater than, so in this case I will use this. Okay, x is less than -2 and x is greater than 2. So I want to find all those values which are less than 2 and greater than or greater than 2. Now which indicates which indices are largest, which x double equals to and max brackets x brackets close. So these are some commands that we'll require while solving some problems. Okay, in addition to the commands that we learned in the previous lecture. Let's get into the problems. Okay, this is the first question. What is the mean, variance and standard deviation of the following data? I have a vector or a variable called val, and these are the values, and I need to find a mean, variance and standard deviation of the following data. So let's get into our R software and try to solve this problem. Okay, this is my software. Now let us solve the problem. I have to create a variable called val. Okay, just I'll say val equals to C. Just let us take the values. Okay, my values are 74, 122, 235. Let us type them. 74, comma 122, then 235, then 111, then 292, then 111, followed by 211, then followed by 133, then 156 and 79, 156 and 79. Okay, so I run this command. Okay, I'm getting some warning messages, but that's not a problem. This is not an error. Okay, now I have this. Now let us see. I try to retrieve the variable val. Let us see. This is okay. Now my values are created. 74, 122, 235, 111, 292, then 111, 211, 133, 156 and 79. So these are the values. Okay, now let us solve the question. What are we expected to find? Mean. First I'll calculate the mean. It's quite simple. Mean, and just write the variable, that is the val. Run it. I get my mean, that is 152.4. Next is variance. Let us calculate the variance. The command is var in brackets val, brackets close, run. Okay, I get my variance, that is 5113.378. Now I calculate my standard deviation. Okay, let us see. SD val. Okay, now I get my standard deviation, that is 71.50 whatever. Okay, so this is quite simple. I hope this is very clear. First I create the vector val, that is the variable. Now I find the mean using mean command, variance using the var command, and then I use my standard deviation, that is SD command. This is question number 1. I'll write the comment that this is question 1. Okay, this is quite simple. Now let us move on to question 2. I will write the comment in the beginning itself, that is question 2. Let us look into the question. What is question 2? Now this is a lengthy question. Now let's see. Suppose you track your commute times for 10 days and you find the following times in minutes. Okay, now these are my commute times for the past 10 days. Now let's create a variable or create a vector for commute time. Okay, let us say commute. This is a variable that I'm creating. So commute is 17, 16, 20, 17, 16, 20, 24, 22, 15, 24, 22, 15, 21, 15, 17, 21, 15, 17, and finally 22. Okay, now this is the variable commute. Let's retrieve it and see. Yes, my variable is saved, that is commute. Now let's try to solve the questions. Find the maximum commute time. Okay, part 1. I have to find the maximum commute time. Find the maximum commute time. Okay, now let's find the maximum commute time. How do I calculate the maximum commute time? Max, the max function. Okay, so when I use the max function, I say max in brackets commute, bracket close, run it. I have some error. Okay, the error was in this spelling. Okay, so I run it again. I get the max commute time, that is 24 minutes. Let's go to question part 2, that is find the minimum commute time. So minimum commute time. This is again quite simple. Command is min commute. Okay, run it. The minimum commute time is 15 minutes. Third part, find the average commute time. This is again average commute time. Okay, how do I find it? Average commute time, that is mean brackets commute. Run it. That is 18.9 minutes. Now fourth one. Okay, this is a tricky question. Okay, now let's see. Oops, the 24 was a mistake. That is to say, this 24 in this data was a mistake. It should have been 18. Now how can you fix this? Do so and then find the new average. Okay, that's now what should I do? I have to replace 24 with 18. How do I do it? That is going to be quite tricky. Let us try. Okay, now in your editor I'll just make a comment. First is replacing wrong element with another element. Okay, now let us replace it. How do I replace? Commute. Okay, I take commute, and what is the value that I need to replace? Okay, now always remember, in this command you have to find the index. Okay, 1 2 3 4. I have to replace the fourth element. Okay, so you will write 4 in the square brackets. Okay, commute 4 with 18. Okay, this is what I am replacing. You cannot write the value, you have to write the index. Okay, so with this command I am able to replace. Now check whether I am able to replace it or not. You see, the fourth element 24 is replaced with 18. Okay, so this is a very important command that you have to remember. The vector name in square brackets, the index number which has to be replaced, and the value with which it has to be replaced. Okay, this is just an operator sign. Okay, assignment operator. Shall we try it with equals to and check? Let us see. Commute square brackets 4, that is the position. Okay, I have to put equals to 18. It's already 18. Let's try or experiment with 19. We can again revert it back. Okay, now let's see. I'm using 19. Okay, now I write commute. Okay, run it. You can see 18 got replaced with 19. So I can safely use the equals to operator as well. Okay, so let's again revert back. Let us make it 18 and then run commute. You can see I have 18. Okay, so I believe that is interesting. Now we'll do the next part. Now I'll find the mean after replacing the wrong value with the correct one. Okay, now it's quite simple. It's the same that we have already done. Mean of commute, so that is 18.3. okay, if I see what was the earlier it was 18.9. Okay, now it's 18.3. Let's go to the next part of the question. How many times was your commute 20 minutes or more? Okay, how many times your commute was 20 minutes or more? If you recall the okay, if you recall this, now all greater than some value. Now this this is the function that I'm going to use, but if I look into the question carefully, it's asking for commute of 20 minutes or more. Okay, that is to say the variable is greater than or equal to 20. Okay, so I have to take care of that greater than equal to. Okay, now how do I do it? Okay, this is quite now I okay, the most important thing, first I will write the comment, that is what how many times was your commute 20 minutes or more. How many times your commute was 20 minutes or more. Okay, this is how you do it. You just have to find the length of commute. Commute is greater than equal to 20. Okay, so just run it. It is fine. So 20 sorry, there are 4 values which are greater than or equal to 20. Last part, what percentage of your commute are less than 17 minutes? Okay, what percent of your commute are less than 17 minutes? Let's put the comment, what percent of your commute is less than 17 minutes. Okay, now it's quite simple. You have to just use a bit of mathematics. Okay, just see now what I'm doing, length, okay, commute, and then your commute is less than, the commute time is less than 17 minutes. Okay, now this will give you the number of times your commute was less than 17. Okay, now this has to be divided by the total number, okay, total number of elements in your variable commute. Okay, and since it is a percentage that is being asked, multiply it with 100. Okay, I hope this is clear. This is the number of times, this command up till here gives you the number of times your commute time was less than 17 minutes. Now this part gives you the total number of elements in that variable commute. Since a percentage has been asked, you multiply it with 100. Now run this, I get 30%. Okay, so this is how you solve this problem. Clear enough? Let's move to the next question. Okay, this is quite simple. Now let's put the comment of question 3. Your cell phone bill varies from month to month. Suppose your year has the following monthly bills or monthly amounts. Okay, now let's create a variable. I'll put the smalls, bills equals to C 46, 33, 39, 46, 33, 39, 37, 46, 30, 37, 46, 30, 48, 30, 48, 32, 49, 35, 32, 49, 35, 30, 48, T and 48. So run this. Now if I see what's my bills get my bill values. Okay, now enter the data into a variable called bill that I've done. Find the amount you spent this year on sell bills. Okay, I need to find the sum of bills. So total I have spent $473 on bills. Okay, then what is the smallest what is the smallest amount you have spent in a month? So I have to use the min command and bills, close and run it. That is $30 is the minimum. Then what is the largest amount you have spent? So for largest I write max bills, run it, maximum $49. Then how many? Okay, so there are 5 times when the bills were greater than $40. Okay, clear? So this is how we solve these questions, right? So I hope you found this session useful, informative. Now get in touch with me. You can get in touch with me on LinkedIn, Facebook, Twitter. You can write to me directly at rajeshtorpala@gmail.com. It would be more than my pleasure to help you out with any kind of help you require in R programming and using R for business analytics and statistics. You have been a great audience. Thank you for your attention. We'll meet you soon.